So what's typical? Hopefully you remember that's how we started talking about measures of center before. Uh, I mentioned last time the three main ways we're going to talk about this: the mean, the median, and the mode of a data set. We're going to focus in this particular video on the mean in question. And we're going to take a look at some data sets that we put some legwork into beforehand. Like we grouped them up into a frequency distribution like this. The same example shows up in our PowerPoint slides. I believe I misspoke when I used some NFL win totals earlier. I think this was from the year 2017 because that year the Browns, bless them, didn't win at all year. There was not a team with 0 wins in that previous NFL win total set, so I'm guessing it was from 2018, but it doesn't matter much in the grand scheme, right? Anyway, so suppose we wanted to find the mean of this particular data set. I mean, I guess we could unpack this back into a list of 0, 1, 1, 1, 2, 2, 2, so on and so forth, and then do the add them all up to get the mean thing. You could do that, but you don't have to, because as it turns out, the frequency distribution format kind of gives us a neat way to do this. You'll notice I've kind of laid this out where there's a convenient other column right here. So as it turns out, what we can do is take our data value here and multiply it by our corresponding frequency, because that would be the same thing like here. 0, we have 1 times 0 when shows up. That product is 0. Here we would have a 1, a 1, and a 1. That's 3. That's the same thing we get if we did 1 times 3. Same thing down the line. 2, 2, 2 would give us 6, which is 2 times 3. I won't keep belaboring the point and hashing out all of those setups as we make our way down here. So, but yeah, assuming I've done all my arithmetic correctly, and I'm pretty sure I did, we get 0, 3, 6, 18, 28, 35, 30. All right. Now, we add up all of these products just like we would have added up the individual win totals. We get 120. Now, when it comes to dealing with group data, you've got to be a little bit careful here. Because what will end up happening very often is I'll have students who say, well, okay, I've added this up, now I got to divide by something. That's how averaging works, right? So they'll slap up there 120 divided by 7. That's not going to work out here. You may figure out, if nothing else, this gives you like a ridiculously high number, like close to the maximum number of games that gets played in a season. So yeah, having as you said, this number is bigger than any of these totals when you work it out. That's bad, right? So remember, when you're working with grouped data, don't divide by the number of categories. Remember, we divide by our total number of values. So in this instance, we need the total of this frequency column. Sometimes I'll see folks who will just kind of add it in at the bottom and say, yeah, that was 32. That kind of gives you a bit of a mental pause. Oh yeah, that's what I need to put underneath here. 120 divided by 32 gives us a mean win total of 3.75, which seems a lot more accurate, as in it's actually possible. So that's kind of the big thing when you're dealing with group data. Always remember, divide by your total frequency, not the number of intervals, groups, classes, whatever you want to call them, that you have here. Don't just look at the number of rows and say, oh, that's what I divide by, because it usually leaves you in kind of goofy territory if you try to claim that as the final answer. All right, so here's one group data example. I want to take a look at one more. It's, again, kind of revisiting something from the past in multiple senses. We're going to look back at those declaration ages from the last section. So looking back at this, hopefully this looks familiar because we had it written up previously. So we're going to follow that same process of multiply frequency in a certain sense. The catch is we don't really have like a single value here, right? Because these have already been kind of grouped up into brackets. What we will conventionally do in this instance is figure out what you might call the midpoint of each of these guys. And then you would calculate the product of those individual values. So basically, what's halfway between these? You can actually just do an average or mean of the two endpoints. 24 plus 32 is 56. Divide that by 2 gives me a midpoint 28. 32 plus 40 is 72. You get the idea. technically, once you got your first midpoint, if you remember how wide each of your groups is, you can kind of just keep adding 8 because that was our width here. So we get 44, 52, 60, and then 68 down there at the bottom. All right, so now we could repeat this process. 5 times 28, 14 times 36, 18 times 44. You get the idea. The slides actually have all of these products sketched out, which is perfectly fine. If you want to do that, like I said, feel free to add a product, but I'm short on space. Do remember the total frequency here adds up to 56. We're going to need that because when we add up all of those products from the PowerPoint slides, I got 2,528. Now, remember, we divide this by 56. If you forgot and divide by 6 here, you end up getting like a mean age of over 400, which is kind of weird because most of the people who would have signed the Declaration, I mean, the oldest one was 70, right? So if they were all born in the 1700s, none of them would be 400 years old now. So anyway, remember, don't divide by the number of groups you have, divide by the total frequency in those groups, 56 in this instance. When I worked that out, I got a mean of approximately 45.14 years. And again, that kind of tracks with the data where the bulk of the ages are sitting right here in this window, so that seems appropriate. One thing I do want to point out before we draw this section to a close is, remember, this is technically an estimate. If we wanted a precise mean, we really do need to go back to the unpacked data, which we could do, but I like you guys too much to force you to add up 56 numbers just to get a little more accurate than this estimate. But keep that in mind that this is an approximate mean rather than an exact mean. The one we saw in the last example, it really was an exact mean because we hadn't done any sort of collapsing, into these brackets. This midpoint is acting as sort of an estimation, so that's where this is coming in as being not an exact mean. All right, so that's measures of center. We've talked about what it means to be typical at this point. So our next section, we'll talk about how you differ from the typical.